4-4, scientific notation. Notice the difference between these two numbers. This one is written in what we call standard notation. This one is written in what we call scientific notation. These two numbers are exactly equal. We need to learn how to translate back and forth between scientific notation to standard notation. And then we need to be able to go from standard notation to scientific notation. So here is how it works. Okay? This number is written in scientific notation. We're going to look at the 5 that goes with the 10, the exponent, and we're going to concentrate on the decimal that's right here. Now, a positive exponent means move to the right. So this is a positive exponent, so we're going to move the decimal 5 places to the right. The number tells you how far to move. So 3.112, 1, 2, 3, 4, 5. Put a new decimal, fill in with zeros. Now, one thing that drives me crazy is for someone to leave an answer on their paper that looks like this, because am I supposed to worry about this decimal or this decimal? You have 2, and then this is kind of a mess. So don't be lazy. Rewrite the answer. That's 312,000. 312,000. That is how you go from scientific notation to standard notation. Let's try another one. 4 times 10 to the third. Remember, positive exponent means move to the right. 3 means how many spaces do I move? Some of you are saying, what about the decimal? In a whole number, we don't usually write the decimal, so it's okay for you to put it in. The decimal lives right behind a whole number. So we're going to take that 4, put in the decimal, move 3 spaces, fill in the zeros, put our new decimal, and the answer is 4,000. Let's try another one. 6.25 times 10 to the 8th. Okay, 6.25, there's my decimal. It's a positive exponent. Move 8 to the right. Start here. 1, 2, 3, 4, 5, 6, 7, 8. Put your new decimal. Fill in your zeros. Rewrite the number. 6, 2, 5, 1, 2, 3, 4, 5, 6, 7 zeros. Let me recount that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right. Then go back and put your commas in. Okay? Okay, try both of these. And then turn the video back on so you can see if you got them right. There's your answers. Now, scientific notation is used to write really large numbers, and it's also used to write really small numbers. The really small numbers have negative exponents, and since we moved positive exponents to the right, we're going to move using negative exponents to the left. Same procedure as before. We're going to concentrate on our decimal. We're going to look at our number, and we go, oh, 4 to the left since it's negative. So, let me write that again. I didn't really leave myself enough room to move. So, 1, 2, 3, 4. Put your new decimal. Fill in with zeros. So, 0.0000135. That's the answer to that one. Okay, let's try these. Remember, negative 5 means move to the left 5 spaces. So concentrate on your number with your decimal. 1, 2, 3, 4, 5. Put your new decimal, fill your zeros in, then rewrite it. 0.00040752. Okay? -3 means 3 to the left. Go ahead and put your decimal in behind the 6. Okay, move 3 to the left. 1, 2, 3. New decimal, zeros, rewrite it. 0.006. Okay, here's 4 more practice problems. Try these, see if you can get the right answer. Here's the answers. I hope I didn't trick you with the 4th one. I was trying to trick you. Remember, negative exponents, move to the left. Positive exponents, move to the right. Okay, here's your video homework. Change all of these to standard form, just like we've been doing. Now, we're going to start with standard form and change to scientific notation. Here's what you need to know about scientific notation. Scientific notation always has a number between 1 and 10 at the front of it. So what that means is you take the first number that's written down, the 5, put the decimal there, and you write it as 5.2. So see how 5.2 is a number between 1 and 10? In my head, though, it's like take the first number, put the decimal, write the rest of the numbers down, and drop all the zeros at the end. You're allowed to drop these in zeros. Then you always have a times sign, and you always have a 10. Now, to decide, first of all, is it a positive or negative exponent? If it's a number bigger than 0, it's going to be a positive exponent. If it's bigger than 0, it's a positive exponent. So this is bigger than 0, it's a positive exponent. Now, the way you figure out what the exponent is you say, okay, where's the real decimal in this number? It's here. Where's the new decimal I'm putting in the number? It's here. How many spaces is that? 1, 2, 3, 4. So that is how you write 52,000. 5.2 times 10 to the 4th. Let's do another one. 6,000. Okay, 6,000. Remember, write the first number down, put your decimal, put the next number. Now, since you're allowed to drop zeros, you could drop all these zeros, and you could just put 6. So, when it's just one number, it could either be 6.0 or 6. Then you've got a times sign. You've got your 10. Then you've got to figure out what your exponent is. If it's a number bigger than 0, this number's bigger than 0, it's a positive exponent. So obviously, this is a positive exponent. So here's the real decimal. Here's the new decimal. There's 3 spaces. So that's times 10 to the 3rd. This answer would be right, or this answer would be right. Okay, here's 3 numbers. Let's write them all in scientific notation. First step. Write down the first number, put your decimal, put the next numbers, stop when you get to zeros. We're going to drop those zeros. Okay, times 10, it's always 10. The way we figure out what the power is we put the real decimal in the number and the new decimal we're moving to in the number, and we count. 1, 2, 3, 4, 5. So 10 to the 5th. How do I know it's a positive 5? Because this number is way bigger than 0. Okay? Next, this one. Start with the 6, decimal point 2, then times 10. Put in your decimal, your new one, your old one. Count the spaces. 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th. Next number, 4.268. Always the first number and then the decimal. Times, always 10. Then we're going to count from here to here. 1, 2, 3, 4, 5, 6. Okay, easy, right? Okay, practice these two. Write them both in scientific notation, then check to see if you got them right. Here's the answers. On the second one, I put both possible answers. I really don't care which one you use, whatever works for you. Now, we have to also be able to translate really small numbers to scientific notation. This is standard form. So, we're going to follow the exact same procedure, but here's what you need to know. Really small numbers. I just realized I told you something completely wrong. Okay, it's not, okay, on the positive exponents, it's not numbers bigger than 0. It's numbers bigger than 1. Numbers bigger than 1. Okay, these numbers are all less than 1. In my brain, I was thinking less than 0. So, correct that mistake. So, all these numbers are less than 1. They're small numbers. They're really small numbers. They're less than 1. So, they're going to have negative exponents. So, you do it the exact same way. You still find the first number that's not a 0, 5, put your decimal, 0.92, times, then you put a 10, just like we did before. Then you come over to your number, put the new decimal in its spot, and count 1, 2, 3. But since this number is smaller than 1, it's a negative exponent. Negative exponent, so that's negative third. Second one, we're still going to put a 6. If you want to, you can put a 6.0. Doesn't make any difference. We're going to have a times sign, a 10, and then we're going to figure out our exponent, okay? Because our new exponent, our new decimal is here. So we're going to find our exponent by counting 1, 2, 3, 4, 5, 6. But it's negative 6. Why? Because this is a number smaller than 1. This answer is great. This answer is great. Both are acceptable. Okay, let's try these. Okay. First, on the first one, you write your 5 down, or you could put the 5.0. Both are right. Then you're putting a times sign. Then you're putting the new decimal into the number and counting the decimal places. 2 times 10 to the negative 2. Why is it negative 2? Because that number is smaller than 1. Let's do the next one. 8.2 times, put your new decimal in the number, count 1, 2, 3, 4. So 10 to the negative 4th. Do the last one. 8.75. Put the new decimal in the number and count. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the negative 8. Okay? Now, before I keep going, I want to say one important thing. What you must never, ever do in scientific notation, you can't write something as, say, 54.2. That's wrong. The decimal point has to go behind the first number. This would be the right way to start a scientific notation. This would be the wrong way. You can't start with 0.78 in scientific notation. You would have to put 7.8. You have to have one number, then the decimal, then the next number. That would be the correct way to start a scientific notation. That would be wrong. Okay, here's a couple to practice. Let's see if you can get the right answer. Then turn the video back on. Here's the answers. Hope you got them right. Here's your video homework. Get it all done. Have a great evening.